Hello, we are Team 7 studying on Burj Al Arab. We'll start off by introducing our team members. Our team members are Oh Jung-hoon, Kong Tae-won, Park Jae-rim, Yoo Sung-ho, and Moon Woo-jin. From this week, we decided to fix the main roles of each team members. Oh Jung-hoon, who is the leader, is in charge of 3D modeling starting from next week. Kong Tae-won designs the PPT, Park Jae-rim is the main presenter, Yoo Sung-ho is the video director, and lastly, Moon Woo-jin is the PPT planner who decides which contents should be in this week's presentation. These roles are fixed for the entire semester, and other minor roles such as the second presenter, researcher, will be changing accordingly to each week's presentation. Now let's get on with this week's presentation. The presentation will be preceded in these contents. We'll give a quick review about our last presentation and move on to project management section and the construction of the artificial island. And lastly, we'll give you a short preview about what we will be studying next week. Previously on our presentation, we talked about the background of why Burj Al Arab was built. Because of the concern Dubai's ruler had about the finite amount of oil, he needed a new way to earn money. For the construction of a special hotel, Al Maktoum chose a young architect, Tom Wright, who he believed could bring out creative results. The architect who was thinking of the iconic symbolism decided on the design by looking at the yacht floating on the Dubai's coast. This yacht ended up being the Burj Al Arab. Starting this week, let's find out what problems were there and how they solved them.
There were some problems in the pre-construction planning phases. It was a problem of project management and bidding design. As a management problem, it was a huge project that cost $1.5 billion, so scope creep was likely to occur. And there was also a problem with a stable delivery of early design in unusual natural conditions. So we have introduced a new approach to this. Atkins had trouble completing a huge building on its own. There was a problem with the employment of workers, the right supplies, but the biggest problem was the construction company to complete the building. So Atkins used the joint venture system. Joint venture means a contract structure created by two or more parties to carry out economic activities subject to joint control. This means that while the overall construction process is managed by Atkins, each part of construction, interior, and material management will be handled by each company corresponding to joint venture. Atkins tried to start construction by selecting companies in various areas of engineering, construction, civil engineering. There was a good deal of work planned, but there was a problem. The client was involved in many parts of the construction process because he was very interested in this project. The selection of company involved a lot of Dubai rulers. It may not seem like a big deal because it's already a selected company, but the problem will occur after construction. As construction begins, Atkins was immediately compromised with each company and proceed with the additional client demands. However, the client is not only involved in the construction process through Atkins, but also in other joint ventures individually. This causes scope creep phenomenon. Scope creep refers to how a project requirements tend to increase over a project life cycle. The client wanted to be completed before 2000 year, so the architect wants to do the same. But if scope creep occurs, it cannot. As the construction period was set, it could have a huge impact on completion. The second is about realization of design. Architects have knowledge of basic structure, but it is sometimes difficult to actually calculate and design the form. So architects and engineers must constantly compromise on this issue. Because of its unique form, Burj Al Arab had a series of these problems during construction. The architect expressed the yacht in the simplest form. In the initial model, there was a high probability that the shape of the structure would be modified by wind. Therefore, it needed a structure to respond to wind load. Through consultation, architects and engineers have implemented structures that can prevent wind load deformation and rooftop structures that can maintain them. The design is based on the frame that holds the sail of the yacht. The front part of the building was also implemented in a simple form, but it also threatened to deform because of wind load and weight of the building itself. Therefore, the rear bracing frame was installed to stabilize the structure. As shown above, intuitive problems could be changed by modifying the design prior to construction, but most couldn't. There are many other problems while explaining the construction process during this semester. But Burj Al Arab's construction period was not enough, so Atkins used the fast-track method. To solve this problem, the architect used the fast-track method. Fast-track method is a construction method in which the design drawings are not completed for the purpose of shortening construction period, and the next stage is designed and construction is carried out according to the completed design. Originally, after the basic design, problems are corrected to complete the design, and then construction begins. But fast-track method is to perform main design and construction simultaneously. Due to the lack of construction time, Tom Light needed to work on it first and then design and construction at the same time. Fast-track method is effective in reducing construction period. It is also a good point of view to look at the use of fast-track method in the actual construction process.
Now let's move on to the construction part. Construction started with building the artificial island. Constructing the island had three major problems. First, the architect and the engineers clashed between must there be an artificial island or not. Eventually, it was built following the client's decision. Second problem was the danger the island had. Building an artificial island 207 meters off the coast and building a high-rise hotel on it had lots of risk factors, such as the destruction caused by either a wave or the structure. Lastly, they needed enormous amount of money. Building of the artificial island costed 3 years of total 5 years of construction period, starting from 1995. The island is constructed 207 meters offshore in 6 meters deep water. First, tubular piles were inserted. Then, 230 pieces of sheet piles were inserted on the inside area where the tubular piles stand. These sheet piles have a length of 45 meters and a diameters of 1.5 meters, and they form a wall of the shape of the island. The sheet piles are held up by connecting them with the tubular piles using the cables. Sand was used to fill up the island inside the sheet piles. Rocks were placed around the outside to protect the structure. Once the rocks were in place and solid, the temporary tubular piles could be removed, and the foundation for the artificial island is done. Now the problem is that the material they used for the foundation was sand. Sand is a very unstable material. The engineers had to build an island out of this unstable sand and build up a 321-meter tall building. How was that possible? Burj Al Arab was able to stand solidly on sand island by the principle of skin friction. Skin friction happens when the skin and skin meet and generates heat. Simply told, it's a friction between the surfaces. When you insert a concrete pile on the foundation made of sand, the surface of many grains of sand meets the surface of the pile. As the force continues to be applied and reaches a certain level of pressure, the force applied is balanced between the sand grains and the friction between the piles. Numbers of piles and sand and the friction between them was the reason 250,000 tons of Burj Al Arab could be built on the artificial island. Up to now, we have looked at the problems of the initial contract phase and the problems that occurred during the foundation construction of the artificial island. In our next presentation, we'll be studying about the problem of artificial island's height. Dubai has high waves because of a strong wind. How did architect Tom Wright, who wanted to lower the height of the artificial island and let the guests get closer to the sea, and the construction engineer who wanted to raise the height for the safety of the guests, solve the problem? We'll talk about this in our next presentation. Thank you for listening.